Hello students, on the behalf of Maharashtra State Board of Technical Education Mumbai, I welcome you to e-contents on emerging trends in mechanical engineering. I am Professor Sachin Patil, working as a lecturer in Mechanical Engineering Department of MICE MIT Polytechnic, Kothur, Pune. We shall continue with our discussion on unit number 1, recent trends in automobile industry. You all are aware of the course outcome. Identify different new systems available in automobile. We shall continue with our unit number 3, that is safety in automobiles. In the last video we have seen active safety system, and in this video we are going to see passive safety system and its integration with active safety system. The key takeaway from this video will be you will come to know advanced passive systems used in automobile system and its integration with active safety systems. Let us see what is passive safety system. Passive safety systems are those that help to protect vehicle occupants from injury during a crash. Their main function is to keep the vehicle occupants protected from the various crash forces. Passive safety features try to ensure that vehicle occupants remain in the inside space of the vehicle during the crash. Crumple zones, for example, absorb some of the crash forces before they affect the occupants. Seat belts, airbags, and headrests help keep the people stationary within the vehicle. Passive safety features reduce the risk of serious injury. Some passive systems are also active, but the key aspect is that they don't do anything until a crash occurs. If you wish to know more about passive safety system, then visit the video. The link is provided at the bottom of this slide. You can also scan the QR code with your mobile. Passive safety system such as pre-tensioned seat belts, airbags, deformation zones protect the occupant of a vehicle and other road users if a crash occurs. It reduces the impact of an accident or the level of injury. Passive safety systems mitigate the consequences of an accident during and after impact. Now let us see something about pre-tensioned seat belts. Seat belts and seat belt pretensioners provide the greater part of the protective effect since they absorb 50 to 60% of impact energy. With front airbags, the energy absorption is about 70% if deployment timing is properly synchronized. What is the function of pre-tension seat belts? The function of seat belts is to restrain the occupants of a vehicle in their seats when the vehicle impacts against an obstacle. In the event of a frontal impact, seat belt pretensioners pull the seat belts tighter against the body and hold the upper body as closely as possible against the seat backrest. This prevents unimpeded forward displacement of the occupant caused by inertia. Seat belt pretensioners thus improve the restraining characteristics of a three-point inertia rail belt and increase protection against injury. Now let us see operating principle behind pre-tensioned seat belts. You can see in the diagram provided here that during an impact, the shoulder belt tightener eliminates the seat belt slack and the film reel effect by rolling up and tightening the belt webbing. On activation, the system electrically fires a pyrotechnic propellant charge. The rising pressure acts on a piston which turns the belt reel via a steel cable in such a way that the belt is held tightly against the body. In this way, pre-tensioned seat belts mitigate the impact of an accident. Now let us see about airbags. Airbag passive restraints are designed to cushion the driver or passenger if the passenger side is so equipped during a frontal collision. The system consists of one or more nylon bags folded up in compartments located in the steering wheel, dashboard, interior panels, or side pillars of the vehicle. During a crash of sufficient force, pressurized gas instantly fills the airbag and then deploys out of the storage compartment to protect the occupant from serious injury. An airbag is much like a nylon balloon that quickly inflates to stop the forward movement of the occupant's upper body during a collision. Airbags are designed to be used with seat belts, not replace them. If there is a collision, an airbag takes less than 1 second to protect the driver and or passengers. If you wish to know more about airbags, visit the video link provided at the bottom of the slide. Various inflators used in airbags are either solid fuel or compressed gas. Solid fuel. This type uses sodium azide pellets and, when ignited, generates a large quantity of nitrogen gas that quickly inflates the airbags. This was the first type used and is still commonly used in driver and passenger side airbag inflator modules. Second type of inflator is compressed gas. It is commonly used in passenger side airbags and roof mounted system. The compressed gas system uses a canister filled with argon gas plus a small percentage of helium at 3000 psi. Once the inflator is ignited, the nylon gas quickly inflates in about 30 milliseconds with nitrogen gas generated by the inflator. Now let us see the timeline for airbag deployment. Collision occurs at 0 milliseconds. Sensor detects collision in 16 milliseconds. Airbag is deployed and SIM cover rips in 40 milliseconds. Airbag is fully inflated in 100 milliseconds. Airbag deflated in 250 milliseconds. So the total time after the collision occurs for airbag deployment is 0.25 seconds. In this way, airbags saves passengers as well as drivers. Now let us see third passive safety system, that is Crumple Zone. Crumple Zone, which is also called as crush space, is a structural feature used in automobile to absorb energy of impact. This way, when someone crashes with your car, the force of impact is much higher than the realized force. The reason is due to the design of crumple zone, which generally uses methods of controlled deformation in the area between outer shell and inner body. A more usual crumple zone is located in the front part of the vehicle to absorb much severe head-on collision which results in maximum number of accidents in a car. But much safer cars nowadays are employing crumple zones in the frontal three-quarter of the car to reduce side impacts too, where the occupants are more prone for a fatal damage. According to a British Motor Insurance Repair Research Centre study, 65% of the accident faces front impacts, 25% rear impacts, 5% left impact, and 5% right side impact. Crumple zone is nothing but a space between the outer shell and inner shell of the car which absorbs the majority of the impact when a vehicle faces accident, saving the occupant's life. To achieve so, the body designers sacrifice the outer body shell by weakening it and hence making it lightweight. On the contrary, the inner shell is toughened and made strong by deploying various strengthening material like composites and steel. A typical crumple zone is built up of many material, combinedly known as impact attenuator. The majorly used material to form an impact attenuator is a high tensile steel, composites, carbon fiber, and aluminium. Some of the most advanced racing cars also use a high-grade energy-absorbing foam that forms an impact attenuator to dissipate the crash energy using a much smaller volume and lower weight than road car crumple zones. Now let us see how the integration of active system and passive system is done. As now you know, safety features in today's vehicle can be divided into two major categories of active and passive system. The active-passive system integration links these and other systems electronically and uses environmental sensor to trigger one or more of them into action. Both active and passive can work in tandem as needed. For example, if your vehicle is closing too quickly on the car ahead, the active-passive safety integration system would identify this as a dangerous situation and start preparing the vehicle in a number of ways to help you avoid a collision or, if necessary, prepare for one. So how this will work? The first step will be active-passive safety integration provides force feedback in the accelerator pedal to let the driver know there is a potential safety issue ahead. This would also include a visual cockpit warning. Second, then all windows and the sunroof are automatically closed. Next step will be it then would proceed to pre-fill the braking system for possible maximum use of the brakes. Fourth, the seat belts are tightened to reduce all slack. Next, seat belts tensioners are activated to hold occupants firmly in their seats. Thereafter, power seats are then adjusted to an optimal safety position for the occupants. Next step will be active-passive safety integration starts to brake automatically with up to 0.3 g deceleration. And the last step would be the driver has had time to apply heavy pressure to the brakes and the ABS system provides maximum anti-lock braking. Stability control is also activated when necessary. The active-passive safety integration system relies on adaptive cruise control in this situation, using radar to measure the distance and closing rate between the two vehicles. It then chooses the appropriate level of actions and intimates them much faster and more accurately than could the vehicle's driver. In this video, we have covered different passive safety systems and integration of active system and passive system. You can test your knowledge on this video through this quiz. Same questions are available in your assignment. Thank you very much and happy learning.